PANIWATER is a Horizon 2020 project which ran from February 2019 to February 2024. The project was a research collaboration between Europe and India, which experimentally validated 6 novel technologies for the removal of contaminants of emerging concern from drinking water and wastewater. The multifunctional reactor was the first wastewater treatment technology developed in the project. It integrates a reagent dosing device and ozone generator to remove contaminants of emerging concern through advanced oxidation processes. An optional ultraviolet light reactor enhances water disinfection, while a lamellar clarifier removes particulate material. A pilot-scale multifunctional reactor, capable of treating 50 cubic meters per day of wastewater, is now installed in the Air Force Maintenance Command of Vayusena Nagar in Nagpur. The solar-powered UVC plant triggers advanced oxidation processes using UVC radiation, which are enhanced by the addition of hydrogen peroxide. The UVC reactor consists in several vertically aligned UVC lamps. Each lamp is contained in a chamber which can host a volume of 80 liters and treats the water in batches. There are 2 field-scale prototypes of the solar-powered UVC reactor. The first is at Plataforma Solar in Almeria, in Spain, while the second is being tested in India, in Nagpur. Both systems have shown complete disinfection and a remarkable reduction of contaminants of emerging concern in treated water, which is safe to use in agriculture. The field prototype can treat up to 10 cubic meters of water per day and can be powered by photovoltaics. The photoelectrochemical system uses UVA lamps to achieve electrochemically assisted photocatalysis. Alternatively, sunlight can be used instead of lamps. The incident radiation activates the electrochemical cell, which oxidize contaminant compounds directly or through the generation of hydroxyl radicals. The prototype is being demonstrated in the campus of CSIR Niri in Nagpur and can treat 1 cubic meter of water per day. The filtration, adsorption, and UVC disinfection system is a self-powered system with integrated photovoltaics. It comprises 3 modules which operate sequentially, removing particulate matter, capturing contaminants of emerging concern, and ensuring final disinfection. A pilot plant of the system is currently providing 300 liters per day of drinking water to the resident of the university campus of BITS Pilani in Goa. Smaller scale systems, providing 30 liters of water per day, are being deployed in villages in the Goa state. The electrocoagulation and oxidation device is made by an electrolysis chamber, a stirring chamber, a precipitation chamber, and a filter arranged serially. It combines electrocoagulation, internal chlorine dioxide production and utilization, and filtration. The current prototype works on photovoltaics and battery backup. It can treat up to 2000 liters of water per day. The device is currently deployed in Auroville. The transparent jerrycan is designed for solar disinfection, or SODIS. It is a 10-liter transparent container with a flat rectangular geometry to increase stability. It is constructed from materials like polyethylene terephthalate, polymethyl methacrylate, or polypropylene. The transparent material maximizes pathogen inactivation through sunlight exposure.
I am Rita Dunapkar. I am a researcher at CSIR, National Environmental Engineering Research Institute, Nagpur, India. I am the Indian coordinator for the PANIWATER project. I am involved in field validation of 3 wastewater treatment technologies developed in the project: the multifunctional reactor, the solar-powered photolytic plant, and the photoelectrochemical system.
The core reagent dosing device of the multifunctional reactor has been developed by Aquasol in Italy.
Io sono Ronzo Santoro, sono il direttore generale e project manager della società Aquasoil. In PANIWATER Aquasoil ha portato, ha reso disponibile l'applicazione di una tecnologia e di un processo con cui è possibile perseguire obiettivi di trattamento di acque destinate allo scarico. fino al recupero e al riutilizzo integrale della risorsa recuperata. Le acque dopo i processi di trattamento, appunto poi anche studiati e sperimentati nell'ambito del PANIWATER, alimenta questo bacino idrico che è formato appunto da risorse recuperate.
My name is Professor Kevin McGuigan. I'm a researcher in the Royal College of Surgeons. My role in PANIWATER is twofold. First of all, I'm the European coordinator of the project. And then from a research perspective, I'm involved in the development of one of the drinking water technologies. That's the transparent jerry can. There are specific scientific challenges associated with the transparent jerry can. We're developing a larger volume container, so that's 10 litres. We're making it out of polypropylene. We need to make the container material sufficiently transparent that ultraviolet light from the sun can pass through it, but we also need to make it sufficiently robust that it can withstand exposure to solar UV for extended periods of time. We've faced several challenges in the PANIWATER project. We've had to deal with the COVID pandemic, and that certainly impacted on our field studies and our interactions with the communities out in the Bundelkhand region of India.
Where we were sitting here in Europe, unable to access India, our partners there got busy and went online, actually held all of their meetings and webinars with government officials, with industrialists, with communities, with women's groups, with schools. They actually managed to do amazing work. We work then with two Indian NGOs, one called DeVault, the Society for Development Alternatives, and we work with TARA, which is the Society for Technology and Action for Rural Advancement. So both of those organisations have a whole team of people who work alongside us in Maynooth University. We are the social scientists really who work with the people in order to ensure there are social impacts of the technologies and then social impacts beyond the life of the project. And my name is Professor Honor Fagan from Maynooth University, and I'm the sociologist working with the PANIWATER team.
PANIWATER has generated more than 50 scientific publications on decentralized drinking water and wastewater treatment. Those publications are available in open access. They are on the project website and on the journal repositories. The datasets that underlie those publications are available too. Out of the 6 technologies that we developed in the project, 5 of them they are undergoing field validation in India, and they will need to undergo industrialization. Discrete elements of those technologies are being used already to provide commercial services. This is the case, for example, of the reagent dosing device of the multifunctional reactor and of the solar-powered UVC plant. The filtration, absorption and UVC radiation device is being used in Goa to provide safer drinking water to local communities, which I think it's a very impactful result of the project. PANIWATER has formally ended in January 2024, but I don't think that the research has ended with the project. We have been establishing a very prolific international collaboration between European and Indian researchers and innovators, and everybody is very eager to see the ramifications of the results that we have developed.